Good morning. There is a correction on yesterday's notes. The homework for yesterday was actually exercise 10, questions 6, 7, 8, 10, 15, 17, and exercise 11, question 1 to 7. So that is what I will do this morning and this afternoon. That is what I will explain as also addition. Thank you. This afternoon we are starting with organic reactions. We're going to look at the addition reaction, but before we do that, let's first go through everything. Yesterday I've made a mistake with the planning, and I've said that you must do exercise 9 and 11, where we are actually busy with exercise 10 and 11. So please revise that, and then tomorrow morning I will send you the memorandums for exercise 10 and 11. Types of reactions of organic chemistry. The 3 types we are going to do. There's actually 4 types if you've seen in the videos. There was combustion reactions, but we're also looking at the following types. Addition reactions. Atoms are added to break the double or triple bond carbon atom. No atoms are removed from the molecule. A more saturated product is formed. The number of molecules decreases as a result of the reaction. Addition reactions is chemical reactions in which atoms or a group of atoms are added to a molecule by breaking the double or triple bond. We are mainly going to look at 4 of them, and this is what happens. If you look here at the bottom, if you see what we've indicated, you will see there's a double bond, and we are going to break the double bond to become actually a single bond, and then we are creating 2 extra bonds where a dipolar molecule can actually bond to with the 2 extra atoms which we have. Okay, so there is then what we're going to use. We're mainly going to use an alkene. Okay, so our first one is hydrogenation. Hydrogenation is the addition of hydrogen to an alkene. Okay, the most common hydrogen we use is H2. Now, each one of our addition, elimination, and substitution reactions have different reaction conditions, and these are the ones you need to study. Guys, please, this is unacceptable if you do not know these ones. Okay, so the reaction conditions is the alkane must be dissolved in a nonpolar solvent, tetrachloride, with a catalyst, and the catalyst that we add is either platinum, palladium, or nickel. And then we add hydrogen gas that is bubbled in a container. No water must be present in hydrogenation. So this is what the word says. Hydro, in other words, we are adding hydrogen. So we look at our first one. So we see there's C2H4 plus H2 with our catalyst that forms a alkane, which is ethane. So what is going to happen? We are going to break this double bond there, and we are going to create 2 places for the new hydrogen to bond. So the hydrogen is going to either bond on this side, and the other hydrogen atom will bond on the other side. So then we will get our new product, which is ethane, and there you can see we've indicated our hydrogens. Okay, so hydrogenation is also a very important application because it helps us to create our margarine, because it actually softens margarine. So margarine is then produced with the process of hydrogenation, where we take an unsaturated vegetable and we make it saturated so that it can actually become a liquid or a solid that is soft, and we also add it in colors and flavorings. Okay, so I'm going to look at question 5.1 in exercise 10 to let us just make sure we understand this. So the first one we have here is but1ene. So we add hydrogen to it. So what will happen? We will break our double bond. We will form two more bonds. So what will we have left? We will have carbon, 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 and our fourth carbon. Then we have our hydrogens, and obviously if we add our hydrogens we are going to get a butane. So that is what we will have, a butane. Okay. Okay, so there we have our compound. Okay. Now next, if we do the same thing with our next molecule, here we have a 2-methyl prop1ene. So what will happen is, again, the double bond will break. We will form two places for hydrogen bonding, and when we are done, we will get a free carbon compound, and this free carbon compound is then 2-methyl propane. 2-methyl propane. Okay, so let us just quickly finish the structure. Again, so hydrogenation. Let's go back to the reaction conditions. The alkene must be dissolved in carbon tetrachloride. Okay, and then we have a catalyst, namely palladium, nickel, or platinum. There must be no water present, and then one of our other reaction conditions, if we go back, is that we will have then the catalyst added, and then we will form our alkene. So that is hydrogenation. Our next addition reaction is halogenation. Halogenation is the addition of a halogen to an alkene. So we are going to add a halogen, either chlorine, bromine, iodine, and it's going to react to form again a saturated compound. The reaction conditions, again, the halogen is dissolved in a non-polar solvent, namely CCl2. No water again must be present. The reaction is a spontaneous reaction, so it takes place at room temperature. There's no catalyst provided, and the reaction proceeds in a non-reactive solvent without adding heat or sunlight. So again, we have our alkene, we have our halogen, the non-polar solvent is there, and then we get our compound. What happens? The bond break, we form two extra bonds, and we get bromine and bromine, and we get our haloalkane. Now, Remember the flop experiment I did when the bromine water didn't have any color? Well, this is actually the reaction we did now. So we added a alkene to bromine water. So if it goes from unsaturated to saturated, remember unsaturated is it has double or triple bonds, while saturated is hydrocarbons that only has single bonds. So it will decolorize, in other words, the brown color will disappear and it will then become white again. Very important. Why did our experiment actually flop? Because the bromine water actually already got in contact with sunlight and it decolorized. Let me just show you another one. Here we have a propene. So here we have a propene. The name here is wrong. It's not propane. It's a propene. And we add chlorine to it. So in other words, what will happen? Our chlorine is going to break. We're going to form two more bonds. And we will get our 1,2-dichlorupropane. Again, let's look at question 5.2. We add a halogen to it, in other words, halogenation. So what will happen here is butane. So we will get a bond breaking, two bonds forming, and we get 1, 2, 3, 4 with our chlorines. With our chlorines forming, and we are going to add now the hydrogens. So we will get a 1,2-dichlorobutane, 1,2-dichlorobutane. Again, remember this happens at room temperature. We must put it in a solvent called CCl2. So it's a dichloromethane, and it is dissolved in here. Again, no water must be present. Very important. If they ask this reaction conditions, you need to be able to label them. In the second one, the same thing is going to happen. We break the bond. We form two places for extra bonds. So we get our 1, 2, 3. We add our hydrogens. Okay. Okay, so there you go. So no byproducts, no water, and this is very important. Next up, we are going to look at the next two, namely, we're going to look at hydrohalogenation, and then we're going to look at hydrolysis, where we add water. Okay, now we are back. Hydrohalogenation is the addition of a hydrogen halide to an alkene. So we have a hydrogen and a halogen that will be added. That is the compound. So again, the reaction conditions, we need to use an anhydrous hydrogen halide. The dry high X or hydrogen halide is directly added to the alkene. So in other words, it is again not in water, and it is just a normal solid. This is to prevent that we form a OH group. So it is again, it's a solid, it cannot have excess water. So we have our alkene again. We are going to break the double bond. We are adding hydrogen and bromine to it, and we will get our saturated compound. Okay, now in this part we must now also look at somebody else, because how do I know, if we go back to our previous slide, that the hydrogen is going to sit on the first carbon or the second carbon, the bromine, if we have more than 2 carbon bonds? So if we look at our propene here, there is 1, 2, 3 carbons. So now this bond is going to break, but where is the hydrogen going to sit, and where is the bromine going to sit? So we are going to use a Russian scientist's law, which is Markovnikov, and we are going to use his rule to determine where we're going to put our hydrogen atom. So he says that during a hydrohalogenation reaction with an alkene, the hydrogen bonds to the carbon with the most hydrogen atoms. So if we take a look at our 2 carbons, here we have 1, 2 hydrogens, here we have 1. So the hydrogen must bond with carbon number 1. The halogen group must bond with the one with the least hydrogen atoms. So the bromine must then bond with the second one, because there is only 1 hydrogen atom. But now, actually, we are always making 2 products, but in the exam we mostly ask the main product or the major product. So the major product follows Markovnikov's rule, and the byproduct or the minor product is actually just the opposite. The bromine will sit on the one then with the most hydrogens, and the hydrogen on the carbon with the least hydrogens. But for exam purposes, the major product needs to be known. Okay, so there it is again. So we look at it one more time. We break the bond. Okay, where must the hydrogen sit? Let's count. 1, 2 hydrogens. There is chlorine. There is 1 there. So in other words, there's 1 and 2. So the hydrogen sits on the carbon number 1, and the chlorine must sit on carbon number 2. So we will then have 2-chloropropane. Okay, please ignore the rest of the name. So that's very important. Okay, so now let's use Markovnikov's rule and let's apply it. Okay, so we have again our butane. So there's our first carbon, there's our second carbon. We have hydrogen and chlorine. So for the main product, and we are only going to draw the main product, is we need to see the carbon with the most hydrogen atoms. So there's 1, 2, and the second one, there's 1. So in other words, the chlorine will sit on carbon number 2, and the hydrogen will sit on carbon number 1. So that means we're going to get the following bonds. Okay, so the chlorine will sit on the second carbon, and the hydrogen on the first one. So if we add now the rest, so let's quickly just add the rest. So there's a hydrogen, there's the other hydrogen, there's the other one, there is the other one. Let's get another place for the hydrogens. and then there's 2 more, hydrogen and hydrogen. Okay, now if we look at the second one, the same thing applies. So let's go back. We need to break our double bond. Remember, we do not have water, it's a dry solid which is added. So the hydrogen will sit on the one with the most hydrogens, and the chlorine on the one with the least amount of hydrogens. So let's just quickly add our, we just make our compound. So it's a hydrogen there, there's a carbon, carbon, carbon. Okay, then on the bottom we need a hydrogen, we need a chlorine, we need a hydrogen, then we need a hydrogen here on top, we need a hydrogen, next we need a hydrogen, and we need another hydrogen. So let's just add the bonds. So we have 1, 2, 3, 4, 5, 6, 7, 8. Immediately I see my mistake. I'm seeing my mistake. I just quickly want to fix the mistake. Okay, so let's just add it there. Sorry. So it is then hydrogen, hydrogen, chlorine, hydrogen, hydrogen, and we need another hydrogen on top. There, we just add our bonds in the methyl group, 1, 2, 3. And there we have our full addition reaction. Okay, last one, hydration. That is when we add water to the compound. Okay, we form an alcohol. What happens is the bond breaks again, but now we get the OH that's going to bond as one and the hydrogen atom. So here again, Markovnikov's rule is going to apply. The hydrogen is going to bond to one side and the OH to the other side, and we will form an ethanol. What is the reaction conditions? We need to have excess water, we need to have a catalyst, H2SO4, sulfuric acid, or phosphoric acid, that will help to form the alcohol. Okay, again, if we use Markovnikov's rule, you will see the OH will bond with the one with the least amount of hydrogen atoms, and the H with the one with the most. So we get our main product and we get our byproduct, or our major product. Okay, so if we quickly do this one again, then we break our bond there. Okay, so we will have the OH sitting on the second one and the H on the first one. Alright, so this is what we will have. Carbon, hydrogen, carbon, 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 hydrogen. Then we have our hydrogen, 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 hydrogen. Then we have our hydrogen, we have our OH together, our hydrogen, and we need to add our bonds. So it's then 1, 2, 3, bond, 1, 2, it's bonded to the oxygen, please not to the hydrogen, 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 and we have our butane 2-ol. Okay, then we look at the last one, the same thing, The OH part is going to bond to the second carbon, and the hydrogen to the first carbon, according to Markovnikov's rule. Okay, so it's then H, C, 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 H. Alright, so then we have at the bottom, we will then find a H, no, we need to put in a OH, sorry, and a H, and then at the bottom top we have a H, no, a CH3. I'm just going to put CH3 there now, so that we can make life easier for us, and the H. So we add our bonds there, so it's 1, 2, 3, 4, 1, 2, 3, and there we have our, let me just correct that. Okay, there we have our 2-methyl propan 2-ol. Both of them are major products because we followed Markovnikov's rules. So, addition reactions in the industry, where do we use them? We use them as polyethylene, which is used to manufacture many plastic bottles, plastic cling wrap, and cable isolation. Polypropylene, we use this addition reaction to form textiles, and PVC to make plastic pipes. Alright, so I want you to go to exercise number 12. So your homework for today, please, if you have done with the other parts, is exercise 12, and it is the addition questions. So the addition questions is question 1 to 5 is the addition questions. If you have any questions tonight from 8 to 9, the group will again be open, and enjoy the rest of the day. Thank you.